So hi everybody, I'm substituting for Ismail Mejia, who unfortunately couldn't come, but I'm going to still talk to you about Apache Beam and HBase. I'm a senior software engineer on Google's data processing team working on Apache Beam and Cloud Dataflow and internal tools. So I'm going to first tell you a little bit about how Apache Beam came into being, tell a little bit about the philosophy of its programming model, tell you a little bit about its project and its place in the Apache ecosystem, and then talk about how it blends with HBase. So Apache Beam is kind of the merger of the Google internal evolution of data processing tools and external, like evolution of data processing tools in the Apache ecosystem. So since the original MapReduce paper came out in 2004, Google has not been idle and has been publishing various papers about data processing tools such as Dremel, Flume, Millwheel, and others. And meanwhile, the external ecosystem has been developing from Hadoop, and all kinds of things came into being, including HBase and Spark and Flink and all others. And then at some point, Google focused much more heavily on the cloud and created Cloud Dataflow, which is a bit more external than previously in the sense that it is at least a data processing tool that others can use. And then finally, Apache Beam was kind of the merger of these two ecosystems in the sense that it is an Apache project based on a programming model originally created by Google. However, it is capable of integrating with the rest of the Apache ecosystem, like running on various runners and so on. And I will talk more about this later. So let us zoom in a little bit on how this programming model evolved inside Google. So in 2004, MapReduce was created, which is basically a huge select followed by a huge group by, which is pretty limited when you think of it. And it evolved in two directions. In 2008, it evolved into Flume Java, which still uses these two operations, basically map and reduce, which are select and group by as primitives, but you can construct an arbitrary graph of them. And this was a batch-centric framework as well. However, in parallel, in 2013, we published a paper about Millwheel, which also supports these two kind of primitive operations, like applying a function in parallel and grouping things by a key, but in a streaming setting. It provides kind of a lower-level API closer to that of MapReduce than to that of Flume Java. However, it had other important innovations, such as being based on event time rather than processing time, meaning the time when an event happened, as opposed to the time when it was ingested into the system. And it was the first streaming system to provide determinism at a time when people were mostly focusing on Lambda architecture and believing that streaming and exact are incompatible. So in 2014, we created Google Dataflow, which is which uses a programming model similar to that of Flume Java, which in turn is similar to Spark. So in that sense, it should be familiar to everybody here. However, it is batch versus streaming agnostic in the sense that the distinction between batch and streaming simply does not exist in the programming model. Like that term does not appear. So it is focused on infinite streams of out-of-order data, and it was already starting to be intended to be portable between different runners. However, that promise fully came into being with Apache Beam. So let's talk more about that. Let's talk more about the programming model first. So as I said, the Beam model published in the paper called Dataflow model, which was before Beam was created. It is focused mainly on unbounded streams of temporal and out-of-order data. This means that time plays a really big role in the Beam programming model. The concept of batch and streaming does not exist there. The notion of time we use is event time, which is when events happened as opposed to when they were ingested into the system, which helps us make a reasonable semantics out of all this. For example, it allows us to treat batch datasets with timestamps, same way as streaming datasets with timestamps. So time is a really big deal there. It is not only applicable to datasets that have time, but its power really becomes apparent when you deal with datasets that do have a time dimension. Once you have unbounded datasets that have a time dimension, and once you do any kind of aggregation, naturally the question of the scope of aggregation arises. And Beam's answer to that is windowing, which is per se not new. So of course, aggregation happens within windows by time. However, windows, unlike some other streaming processing frameworks, are scoped to a key. So there is no global splitting of the time axis into windows, like 5-minute windows, but instead you can have more complicated windows. For example, a key can be a user ID, and you can window events associated with that user into sessions of that user. So this is something that you cannot do in a framework where time is a global thing as opposed to a per key thing. And finally, the other important concept in the Beam model is triggers. So once you're doing aggregation in an unbounded out of order stream, you start asking yourself what happens, like when do you declare an aggregation for a window complete? So since things arrive out of order, you can get late data, like you can get data points arrive really late, so the window might actually not be complete by the time the end of the window technically elapses according to the wall clock. So triggers control when do you emit like tentative results from a window, when do you like emit something you call a complete result, and when do you like completely discard that aggregation and just drop all further data, stuff like that. We like to summarize this in the form of 4 questions. What are you computing, which is the core of the programming model, that transforms themselves. Where in event time are you aggregating? This is what windowing is all about. And when in processing time are you emitting results, and how do you refine results if new data arrives? And that is what triggers are for. So these are like the 3 or 4 core tenets of the Beam model. I defer you to the Beam paper and the various Beam talks for more details about that. I'll talk very briefly about the rest of it. So transforms are pretty simple. There are element-wise transforms, which are basically map operations, and there are various kinds of aggregations, such as simply grouping things by key, or like adding things together, or computing per key sums. That is simple enough. And you can like group transforms into composite transforms just for the sake of having a bigger unit of abstraction. This is an example Beam pipeline that demonstrates what kind of transforms you might be using. Of course, pipelines don't have to be linear like in this example, but this is just a classical word count example. Like you're reading from files, you're applying a flat map operation to split every line of files into words. You filter it, you aggregate the words to compute the count of each word, and then you format the result into strings, and you write these strings to text files. So simple enough. That's what transforms look like. Windowing, I already basically discussed that windowing happens per key, and this is really important when you're dealing with stuff like user activity streams. And windowing is, of course, necessary when you do aggregations over unbounded data. This is something that does not come into play traditionally when you're dealing with batch data processing, like Hadoop. However, once you have a programming model that encompasses both batch and streaming, you start thinking like, I wish I had windowing in batch. Because then you can use exactly the identical code that you use for streaming, and you can simply apply the same code to historical data that's stored in some batch storage system. So windows are necessary both in batch and streaming, but they're particularly necessary when aggregating unbounded data. Now, triggers, as I said, they control when do you declare the results of a window complete. They are often defined relative to something called watermark. So for example, when you're reading data from a particular unbounded source, like reading from Kafka or PubSub or something like that, oftentimes you want to say that I want to declare a window complete when I'm relatively sure that no data later than this will arrive. And in some cases, when reading from sources, you can have kind of an approximate promise of how late the data in the source can possibly be. This is often challenging to implement, but sometimes possible. And watermark is this kind of promise from a source on how late will be the data that is emitted from it. So triggers are often relative to that. So for example, you can say that you want to emit results when the watermark reaches the end of the window, but you want to also emit early results of an aggregation for a window every minute. And when late data arrives, you want to emit results like every time a single new data point arrives. So this is just an example code snippet that uses windowing and triggers and some kind of aggregation to apply them to. Again, let's not delve too much into this. I just want to tell you what concepts are there, and for details, you will need to look at the more detailed talks because I just don't have time to explain that here. So basically, again, the Beam model summarizes the what, the where, the when, and the how, and it encompasses various kinds of use cases, from classic batch processing, where you're just processing everything in one go, to batch or streaming processing when you're windowing things into fixed windows by time, to cases when you emit tentative results and speculative results and late results, and when you have more complicated windowing, like windowing by sessions. So it's pretty flexible in that sense. and it's been really getting traction, and I believe it has heavily influenced the programming model of Flink, for example, recently, and I believe Spark too. So now let's talk a bit about Apache Beam. So Apache Beam is the Apache project that grew out of Dataflow, and it implements the Beam model. And here's what it contains. It contains a bunch of SDKs for users to write pipelines in. Currently, it's a Java SDK, so you can write pipelines in Java, or you can write them in Python. There is a Go SDK in the works. And I guess it is possible to implement other SDKs as well, though it is quite a challenging task. And Beam contains a set of runners as well. So Beam pipelines can run, initially, they could run only on Dataflow. However, from inception, it was intended to be runnable on different backends. And currently, you can run Beam pipelines unchanged on, for example, Apex, or on Flink, on Spark, on Dataflow. There is an in-progress implementation of running pipelines on Gearpump. Some companies like Alibaba, I believe, have their own in-house runners in development. I think IBM has one too. So it's really like a sprawling big ecosystem with lots of people participating in it and constantly growing. And of course, there is an in-process runner that executes the Beam semantics sort of as a reference implementation for testing pipelines. So the vision of Beam ultimately is like ultimate portability. So not only you can run pipelines on different runners, but ultimately, you will be able to use, for example, a transform written in Java in a pipeline written in Python. And this is achieved through an abstraction layer called the FN API, which we also call the Fun API. Again, I cannot go into too much detail about that, but it is important to remember that this is the degree of portability we're shooting for. So we're abstracting ourselves away from both language and runners, so that all of these parts can be developed independently, as opposed to like developing a whole new data processing system for processing in Python.
What language is Beam itself?
Different components of Beam are in different languages. So the Python SDK is in Python. The Spark runner is in Scala and Java. Dataflow backend is in C++. Dataflow SDK, Dataflow runner for Beam Java is in Java. So there is no single thing called Beam. It's an ecosystem of components. Hope that's clear. So this is basically a repetition of that, so I'll skip it. This is a bit of a timeline. So Beam Beam as a project came into being in early 2016, and I believe it got the largest unanimous number of positive votes for including into the Apache ecosystem in the history of the Apache ecosystem. So it's kind of nice. And through 2016 and part of 2017, there's been a lot of like de-Googlification of the Dataflow SDK code base to make it legitimately vendor independent, and stabilization and polish and lots of new features and implementation of all these new runners, so that we could say that it is truly a vendor independent and runner independent project. And that culminated recently in May when the first stable release of Beam was released, Beam 2.0. So now it is like legitimately declared production grade. You can use it and not worry that we will constantly break it. The Beam community, it is really a sprawling community. There is like almost 200 contributors. There is dozens of committers from several organizations, and no single organization has more than 50% of committers. So it is not a Google project, emphatically. It is a community project by now. It is generally very active, and one of the important parts of the ecosystem is that it has over 20 connectors to different storage systems. And that's where we come to HBase. So again, many uses of Beam are simply pipelines that take data from one place and copy it to another. This is such an important use case that a really important part of the Beam ecosystem is these connectors to storage systems that can read and write from them. There is a bunch of connectors for the Hadoop ecosystem, and I emphasized HBase here, and I also emphasized Bigtable, because that is kind of the paper on which HBase was based, and they have a remarkably similar API. And actually, the way that you use them from Beam is almost identical. Perhaps it will be possible to completely merge them at some point. So this is what it looks like to read or write HBase and Beam. Like you apply a transform called like read from HBase. You specify like a configuration, a table ID, a scanner, a filter, or something, and you get a collection. It is not entirely unlike a Spark RDD. So from in terms of programming in the pipeline, it is basically the same. It's a logical data set. And likewise, you can take a data set of mutations keyed by row key and say, I want to write these mutations to HBase. This API is likely to change because it was intended to be very similar to Bigtable, but in retrospect, this was not such a great idea. So we'll probably change this to just like write a data set of mutations. So how does this work internally? Internally, all of Beam's IO connectors are simply Beam transforms. So they're simply composite transforms that accomplish in parallel the task of ingesting something from a data system or writing it in parallel to there. So oftentimes they're a simple like map. For example, connectors that write something to a system are often a simple map transform that takes the data set and writes each record to the system. When reading data, it is a little bit more complex, and I'll maybe talk about that. But the important part is that since the Beam programming model is agnostic to batch versus streaming, all of these connectors also are. So there is no such thing as a like batch writer to HBase versus streaming writer to HBase. There is one thing that writes to HBase, and it's usable in both batch and streaming pipelines. So for example, the writer is basically a map called the Pardo in Beam terms, and it does stuff like connection management, like not recreating the connection for every element and trying to write multiple mutations at once, and like tearing down the connection when the task is done, stuff like that. So it's pretty self-evident, and it uses standard HBase functionality for that, like buffered mutator. For reading, it looks like I don't have much time to go into details of that, but I'll emphasize a couple of things. So first, of course, reading involves splitting into parts for parallel processing, splitting the specification of reading. It is a lot like the Spark connector that the previous speaker talked about. So we also look at which region servers involve the range that we're trying to read. And there is stuff like communicating to the runner a hint about how big the data set is going to be, or the runner telling us how fine-grainedly to split it. And another really interesting thing is something called dynamic splitting. So the problem of stragglers is probably known to many people in this room. So stragglers are shards that take a lot longer than other shards, and because of that, the rest of the job waits for the shard to complete. Beam includes an API for dealing with that. Only Dataflow of all the runners implements that, but I'm hoping that this will change because the details of that are public. So Beam uses something called dynamic splitting, where we split shards while they run. This is basically a form of work stealing, and it seems pretty simple. It is kind of a nightmare to implement. It was basically my main project through my 3 or 4 years at Google, but it is remarkably effective. It is a really simple idea, so that is really all there is to it. You split shards while they run. There is all kinds of interesting details in that, and I'm happy to talk about them. But these are kind of the effects that it accomplishes. So it cuts down stragglers. It cuts down stragglers by a lot, even in pipelines where the data is supposed to have been very balanced. So this is a classical like TerraSort workflow on this graph here. And most importantly, it allows auto-scaling. So with dynamic rebalancing, it becomes possible to not decide upfront how many workers you will need. So this is a really powerful feature. I'd be excited to talk about that to people. That's about it. So if you want to learn more, there is various Beam talks, and there is this talk that's particularly dear to my heart about how we deal with stragglers. But it is kind of out of the scope of this talk, the rest of it. So that's it. Thanks.
Questions?
So what is the implementation infrastructure for doing Apache Beam stuff? Let's say, keep taking Apache HBase as an example.
Sorry, are you asking what infrastructure is being implemented on top of?
Yeah, what kind of infrastructure would be required if I have to implement Apache Beam on top of Apache HBase?
That completely depends on the runner. Beam requires no additional infrastructure. If you have a Spark cluster, you can run Beam pipelines with a Spark runner. If you have a Google Cloud account, you can run it on the Google Cloud. So yeah, Beam has no additional requirements.
Okay, thank you.
Thanks.